Okay, today on the bench we have a Subaru ECM for Jason, ticket number SRP 5AD6RPL. You can check the ticket status on blackhorserepairs.com. This repair will be a little bit different than the previous one I did, because previously I was working on my own board, so I always had an opportunity to go downstairs and put it in the car, test it. This one I will not be able to test, as most likely it will not work on my car, because they're most likely tied to the VIN of a particular car. So I'm going to address all the potential issues on top of the primary issue. This one, standard, and no misfire or no control signal on the 6-cylinder, the fuel injector on the 6-cylinder. And as we talked with Jason, we concluded that this is most likely the issue that I described in a previous video. So in this video we're gonna the other thing different in this board is that at least supposedly it has no prior repair attempt, which means that we're gonna have to take off the insulator, that layer that makes the board waterproof, and then we're gonna make it waterproof after the rework. If the chip has not been moved or touched and there are no prior repair attempts, we're not going to be changing the chip, as it probably isn't needed. Based on the discoloration over here, I assume this is not the computer that came with the car. It probably has been replaced. It looks like it's been sitting out somewhere in storage. It might be the reason. The other reason for this discoloration could be the liquid damage. So we'll see if there is a liquid damage on the board. If there is, we'll try to fix it. Otherwise, we're gonna check the harness connections. Just put new solder on them just to be sure, and we're gonna resolder the IC that is responsible for a control signal on the fuel injector. Okay, first thing to do is to open the computer. There. Okay. The computer's out. Let's get some focus. All right. Now let's do some measurements. Okay. And here's our guy. That's our faulty pen. Over here. What's this? Okay. You can see that it hasn't been touched. Let's see. Okay. Okay, it's making good connection through the harness, or at least on initial measurement. Let's see the state of pens. Get some better light. this looks good to me. But I'll probably, just to be sure, I'll put some new solder on it. Let's see, which pen is it? It's this one over here. Okay, this is the pen. It looks good to me. No corrosion, no oxidation, nice and shiny. No. It's good. I will put some more solder on it, just to be sure, but it looks good to me. Okay, in that case, let's take a better look at the pen in question over here. And yep. Let's see over here. Okay. So this looks, yeah, this solder, yeah, look at that. Yeah, that's the problem. So it's not the board. I think they just used really the solder that they shouldn't have. So after doing this, look at that. Once I just push it in like this gently, right? You can see how the solder is bending, deforming. So after pushing it like this, the car will lose the misfire for a little while. Day, maybe a week, maybe 2 weeks. So that is one way to confirm it. If you just push a little bit over here, it's better to use a toothpick because it's softer. But if you push it like that on this pen and put it back in the car, the misfire is gone, then you know exactly what the problem is. But we assume that we know that what the problem was. So let's get a tool. Maybe this one. Yeah. Okay, all this mask will most likely just be removed by the temperature alone, but if not, I'm gonna keep my tool handy over here and just scrape it a little bit here and there. But before we do that, we're gonna get some cotton tape. One thing I didn't mention last time, I was talking about those capacitors, those small capacitors around it. That worst case scenario, if I knock them out, right, I can replace them, this one and this one, right? And maybe this one. But there's a very important thing that I forgot to mention. These are not your standard capacitors. These are automotive capacitors. They're significantly more expensive, and the difference between the regular ones and these ones is basically the this layer on those on those electrodes, on the connection on one side and the other side. There is additional layer of a flexible material. which makes them basically last longer when vibrations are common, right? And in the car, obviously, especially with misfire, this board will suffer a lot of vibrations. So those capacitors, if exposed to too much strain, they will short out. So if you take out this capacitor and replace it with the regular one for like 2 cents or whatever, they will not last as long as these ones. So what I'm doing, I'm just taking extra precaution and covering them with cotton tape so they don't get exposed to too much heat. Before I just covered the electrolytic capacitor because I just didn't want it to explode on me. Come on. But since this board is not mine, I'm going to take every precaution I can. Okay. Alright. And these ones are pretty far. Why am I using these tweezers? They're bent. Okay, that's better. Well, not perfect, but better. Okay, I'll be able to hold it. So these capacitors are all covered. I'll put one more on the electrolytic capacitor. Just to cover it a little bit more. We don't want any explosions. Let's get some better tweezers. Just like that. Okay. Now this guy is covered. Okay. Now we're ready to take our chip off. Now I'm gonna use these tweezers. Yeah, I can. Okay, these are much better, much more massive. Okay, tools back in place. Captain tape. Back to where it belongs. And I'm just gonna need other 330. We need 360 something. Oh, actually, hang on. First, let's do the preheating. The board is not cold, but still, it's always a good idea to preheat. Because if you start just resoldering when the board is cold, you might do some serious damage. That will be very difficult to diagnose, very difficult to fix. I'm just using 100 degrees, about 130. And slowly bring it to the temperature. The better way would be to have a preheating station. That also makes it a lot easier to solder. The whole point is to raise the temperature of the element high enough so the solder flows, but not heat stuff around it. But for that you need a much better tool than I have at the moment. So I need to just make up with skill. Yeah, you can use cheap tools. You can use absolutely cheapest tools and still get the job done. The better tools just make it easier and quicker. So it's not necessary to have good tools. I need to check Slack. Okay, nothing that needs my immediate attention. Okay, back to heating. Let's heat only this guy. Let's see how this mask is behaving. Yeah, it's some kind of glue. It should get off with alcohol easily. But we'll see about that. Alcohol and toothbrush most likely will get the job done. Okay. These guys, this one. I don't want to remove more than I need to make this repair. Okay, and now let's get the high quality Q-tips. The difference between the high quality and the low quality, other than the price of course, is that those high quality leave a lot less those little strains of whatever it is, cotton. I think it's cotton. Okay. See, almost no residue. regular cotton swab, it would be already a disaster here with all those little strains. Some left hand action. Alright. More alcohol. Okay, now let's get rid of those big chunks. Kinda gooey. Change the perspective. Okay. Let's heat it up a bit. I don't need to remove all of it because once I get the chip off, it will be much easier to clean. I just don't want it to stick with that glue. Just a little bit over here, this little blob. And the chip is more or less good. Now, let's get the nice view on it. And now temperature about 370. Don't take my temperatures literally because it's not the temperature that is set on the device is not all that is needed. You need to see the temperature with your eyes under the microscope. Depending on what temperature you set, because the board is going to start taking all that heat, dissipating it quickly. So you read that the solder melts at set temperature, you set that temperature 10 or 20 degrees above, and it doesn't want to flow. Because the temperature set on the device is not the only factor, basically. Okay, now let's start heating it a bit and see when the solder is going to start flowing. There, some of it is flowing or starting to flow. Okay, check this off. Let's inspect the pins. No ripped pads. Yeah, see this? That's not what the solder is supposed to be doing. This is some weird solder. I think that's the only reason why this problem occurs on those cars. But why only this chip? That's interesting. Let's see. Or maybe this whole solder mask or this insulator that they put on it, maybe that's what's causing it. Okay. So now, expensive Q-tip. Some alcohol. Oh, and I forgot to turn off the powder. I don't know. It always seems to me like this side that is problematic always looks a little bit different. Like the solder is less shiny on this side. Or maybe I'm just imagining it because I know where the problem is. I'm just looking for confirmation. This is our pin. I don't know. I don't really see anything wrong with it. Okay. Ready for step 2. Flex here. Soldering iron on the tip. That's not the right tip. And there you go. Soldering wick. First I'm going to put some lead-free solder on it. Let's do temperature 370. It's going to be a big one, but from prior experience It requires solid temperature. Especially when you don't have a preheater. Oh, it's flowing very nicely here. See the difference when you have the right tip? Previously I was doing it with the small tip because my iron was already hard. So I just didn't want to change didn't want to lose time changing the tip. So I was just working with higher temperature. And now it looks like my temperature is even a bit too high. But as long as you're not using any force, it should be fine. Although it all depends on the board. Some boards are so thin, so flimsy, that you just touch it with an iron that is too hot and the pots just fly off. And then you have a big problem. A little bit more. Okay, that should be enough. Okay. Now let's just clean it, see what it looks like. Things are looking good. I left some solder in that one hole over there, but that's no issue. You see the big difference between those Q-tips, those expensive Q-tips, and those regular ones that you get for, you know, for like a few bucks for 500 of them or something. It really makes a big difference. I use, well, when I work on customer boards, I use better tools, I use better equipment, and you know, when I work on my own stuff, I can take some time to clean off all those tiny hairs. No biggie. Okay, and let's see the chip. Okay, 230, 275, 280. That should be enough. The chip is not gonna dissipate too much temperature, so it can definitely be lower. Maybe a little bit more over here. Looks like there's still a bit of solder in there. Okay, that should be good. Clean the tip. Keep it at 280. And let's get a Q-tip. Alrighty. Oh, that's dirty. Oh, that's a big flux blob. Let's get more alcohol maybe. Let it soak for a while. I don't want to use force. I prefer alcohol does its magic. That I haven't seen. Was there like factory flux on it maybe? My flux usually doesn't do that. Oh, I know what it is. Okay, I know what it is. It's that glue. It's gotta be that glue. Mixed with flux. Okay, in that case, let's give it more alcohol and see if I can do it with alcohol alone. If not, I need to heat it up. I don't want this glue to mix with my flux because it's just not gonna work. Okay, and the ultrasonic cleaner you go, because this is not gonna work. Okay, let's let it sit in alcohol. I'll heat it up later, or I'm gonna turn on the ultrasonic cleaner, which also I'm not too fond of doing with chips like this, because they're gonna start dancing in there. And this cleaner, and I'm not sure if it's good for the chip. Okay, now $280 on my iron, that should be enough. Clean the tip. Oh, the temperature is too high. It's not sticking to my iron. See how it escapes? Yeah, the temperature is too high. Because 280 is good for a smaller tip. Big tip is gonna retain a lot of temperature, so it's just too high. I already have a new soldering iron coming. Cartridge-based tips. So they transfer energy a lot better and they're much more accurate. This one, you know, I set it to, what do you call it, 260 or whatever, but I don't know if that's actually the temperature. Oops, that was risky. I was risking my solder caught the pin and I pulled on it. I could have ripped the pot off. That was very risky. Let's not do that again. See all those ground pots, how quickly they dissipate. This would be a little easier with a smaller tip. Well, I can work with this one. Well, at least these little pins would be easier, but then this ground pot would not. I'll have to increase the temperature for the ground pod. And that's in a second. We need more flux. Just a little bit of solder on those. We don't need too much because after all, that's so much solder. Okay, and now the temperature, let's go to 70 to 80 for the ground pot. Okay, let's see. To gold. Let's try 310. That's better. I'm not quite there yet. I don't need to reflow it at this point. Soldering a bit harder is going to reflow it. Just when I put enough, I'll let it solder on it. So it'll hold. But hopefully without making bulges, so the chip can lay flat on it. Okay, that should be enough. I don't want to overdo it. Okay, now let's see what's it gonna look like after cleaning. Okay, I'm gonna redo it with smaller tip. The center is good enough. I don't want to use the soldering paste low melt on it as I did for my device, because I don't really trust the low melt solder to be holding the chip. Okay, now let's reduce the temperature. Let's see the chip. Okay, Q-tip. That glue is awful. Awful. And I need to remove all of it, otherwise it's going to be a problem. But after soaking in alcohol for a while, it's actually getting a lot easier. It's getting off a lot easier now. Let's see that little thing. Come on. Yeah, and there's more here and there. Just a little bit here. better you clean it, the easier it'll be to solder. That's a lot better. A lot better. Yeah, and we can almost read it now. Yeah, let's see, 9000724. That's our chip. All right. Think a little bit more on this side. Yeah, maybe just a little speck over here. Yeah, and that's what the chip should look like when it's clean. There's still a little bit of lead-free solder in the center here. Just a tiny little bit. But I'm not worried about that. It'll mix with leaded solder and that'll be fine. Okay. Iron's at 100 degrees. Let's change the tip to the precise one, or at least more precise one. Yeah, technically you can do it when it's hot if you're not afraid of burning yourself a little bit. There. Okay. There's soldering. And let's do 270. 270 should be okay. 270. Oops. Where are you going? Oh, it's running away. Looks like I need to hold it. I was hoping it would just stay in place, but nope. Okay, now come on. Get that nice leaded solder. There. Okay. And a bit more here. Oh, ran out of flex. Okay. And this one doesn't want to flow. But that's okay. Oh yeah, that's enough. Yeah, it's not really flowing, but that's fine. It's almost flowing. Oh, now it's flowing as the chip heated up. Okay. Okay, I don't want to leave that big bulge over there, and if I do, let's make it in the middle. Yeah, this thing, yeah, that should be alright. Okay, so the chip is prepped. The board is, well, the board is not prepped. I was going to redo some pins over there, so let's get the chip away. Let's get some temperature, maybe, oh, no, 270. And I didn't like these guys over here, so let's reflow here. A little bit more solder. That's maybe too much, but I can remove excess. Okay, well, this one has a lot of solder. And we need a bit more here. There. That's a lot better. Yeah, and the rest looks good. Okay, let's just clean it quickly. See if everything's good. There's a bit too much solder on the left over here. I'm not sure if that's not gonna bridge. Oh, but even if it does, that's all That's all ground over here. You know, these 3-4 pins over here, that's all the same pin, so it can bridge on me, I don't care. But I prefer it didn't, so let's remove a little bit of it. It's like you can always put more solder, but if you put too much, then you need to take off the chip and do it all over again. Which is no biggie, but I prefer to do it just once. Very odd angle, but let's see. Okay, that's a lot better. They still have a little bit more solder than the other ones, but at least now it's not as prominent. Alright, the chip is ready to be resoldered. Looking good. Okay. Soldering station. 5.5. Temperature of the other. 370, 360. 360 should be enough. Now, let's catch a good angle on it. Dry it off a bit from all that. Oh, that's flux, that's not alcohol. Okay, so that's fine. There's still some flux on the chip as well. Okay, chip orientation. Where's the dot? Where's the dot? Okay. Let's decrease the airflow 4.5. Tweezers. Nope. Even too much. Let's do 4. Wow. You can see it's already flowing on the outside. Not on the inside though. Oh. Come on, now it's burning. There. I didn't make it dense, but kind of an odd angle here. Let's let it cool down and inspect. The chip is definitely in place. I'll check the alignment once it cools down and rework the pins, and that should be it. Okay. Alright, so we have a next day. The chip is resoldered. Went through ultrasonic cleaning. Now it's time to seal it. Now, when putting it in ultrasonic cleaner, you can see that this part over here, right, that was covered by Kapton tape, it still has a little bit of residue. But I'm not worried about that because I need the outside of the chip, or the area near the chip, to be clean. So this other mask, or the UV mask, actually sticks to it. The only reason it wouldn't stick is when there's flux. So the only reason for using ultrasonic cleaner is to clean all of the flux, not to clean the actual board. You don't want to keep it for too long, because not far from there you have a crystal, and you know, if you hold it long enough, you're gonna remove the original factory glue that you see over here. So we don't want to do that. So it's just clean enough to put the mask on it. And now let's just get some, okay, some mask. Let's see if this one's still good. And let's hope my microscope's not gonna lose any footage, because I lost like 2 hours of footage from the microscope. And today I had to pay $60 for a software that recovered it for me. So I'm already down on this repair, but such is life. Okay, the layer must not be too thick, otherwise the inside is gonna still be molten. It's not gonna set, because the UV light won't be able to get there. And it's better to use 2 layers than the 1 thick layer for that very reason. So we don't want anything floating under the chip, and we don't want any bridges on the pins from any potential liquids that might get into the car. It's actually not even the liquids, it's just it's cold outside and you put the heater inside, then there's bound to be some condensation, some humidity in there. So it's best to just seal it nicely. Although I haven't sealed mine on my car, and it's winter here, it's pretty cold, snowy and everything, I have no issues still. It's on my to-do list to seal it. It will also slightly improve the stability of the chip, so it's also good for vibrations. And some UV light, and let's give it a few seconds under UV light and see how it's sealing. just after a few seconds we should see a significant difference. Yeah, so it's set on the outside, but if you press on it, it should still be liquid inside. Well, actually, yeah, it's a little bit soft over here still, but it actually set very well. We'll see if the second layer is necessary. Maybe not. The UV mask goes a long way. You don't need a lot of it. It's very useful when doing pin restoration and traces restorations, soldering the wires, all that good stuff. Provided that you have good UV light. I don't. But I spent $60 on the software to recover one video, so I'm not going to be buying UV light. This one's kind of flickering and it turns on off. There's some cold solder, I think, in the switch. I'm not sure. I could fix that as well. But, okay, let's see what we got now. That looks good. I could put more of it here and there. Actually, I just remembered you don't necessarily need the UV light because the sun is going to do the same thing, just take much longer depending where you're located. But if you're somewhere in a sunny place down south, you don't really need the light, the UV light. Let's see if it's nice and solid everywhere. From the top where I have the better light. Oh, that is not done yet. And a little bit over here. That will also help keeping the chip in place. So, and if you have to remove it next time, you just heat it up and that mask should just dislodge easily. It's not like crazy glue or anything like that. Okay, and that should do it. Okay, for now let's just put it like this. Let it drain. And my crappy UV light. Like that. It went out again. Okay, it's gonna sit under UV light for a while because I want to make sure it's really solid. Then I'm gonna expose it to some sun as well. Sunny weather today. Very cold, but sunny weather. And the board is ready to be shipped. Today is Friday. I'm gonna ship it tomorrow in the morning, UPS ground. So Jason, you should get your board sometime next week, and that should be hopefully the last time you've had a misfire on your car. Okay, 2 more seconds. Usually with a powerful UV light, it takes about 20 to maybe 40 seconds. With the light I'm using, it's obviously going to take a little longer. So I'm not going to bore you with this process, so let's just check out under the microscope one last time. Yeah, so tweezers. So you can see this is even more than required on this side, and it's everywhere around. So this should be good. All right, that's the repair. Thank you very much for watching. Jason, thank you for your business. And I'll see you guys in the next one.